Hello and welcome, everyone. We are here in the nature wild of Costa Rica to introduce you to our presentation that is breaking free from legacy virtualization, embracing KubeVirt for cloud native workloads. It's a pleasure to be here. I introduce the agenda and then I introduce my friends. Breaking free from legacy virtualization has a specific topic that is related to this kind of trends, virtualization idea that we all have, and the challenges. So, the introduction will dive into how we do virtualization in these days, how it was done in the past, and the challenges that we had with traditional virtualization, how KubeVirt, that is the solution that is the main topic of our presentation, is solving the problem for everyone, the key benefits of migration to KubeVirt from virtualization that can be, from the legacy perspective, really whatever, and we will skip the demo because today our main focus is to go for giving a landscape, but later we will give you our contact in order for you to have us as a reference and ask whatever question. We have an offline demo that is working very good with Terraform and LibVirt providers so that you can use a nested virtualization. We have some use cases, examples, and then the conclusion with question and answers will be driven by Platform Con offline. So let's start with us. I'm Fabrizio Sgura. I'm the chief engineer at Veritas Automata. You can scan my QR code. I have 30 years of tales to tell about IT, but this is not the main point. And I'm going to introduce my friend
Right,
Gerardo,
you looks younger. You look younger.
just because I have long hairs.
Yeah, of course, it's a good strategy. Hey, people, my name is Gerardo Lopez. I am principal engineer in Veritas Automata. Both we are Cubesonauts. Right now, we are very proud have this opportunity to explain you about KubeVirt virtualization because Fabrizio regularly the people think virtualization a virtual machine, oh, it is so past, it's so old. But what happened right now in this business, how this technology come in, for example, different product, different companies. Right now, I'm thinking, okay, I have my virtual machines, I have good products, this getting money, but I don't want to migrate microservices. I want to integrate Kubernetes, but I want to continue using virtual machines.
That's true, and it's raining here. So if you hear the rain, that is not virtual. Let's start diving into the introduction. Let's think about how virtualization is conceived today. It is virtual machines, how the physical hardware can be partitioned. Who started that? Gerardo, you can imagine that in 1960,
Oh,
at that I was not born at that time. IBM was already
wow.
doing something at that time. Have you read something about that?
Yes, of course. Legally virtualization emerged in the 1960s, originally developed for mainframe computers by companies like IBM, like you mentioned it. The CP and CMS, it means Control Program Cambridge Monitor System, for its mainframe system, introduced the concept of time sharing through virtualization. This allows multiple users to interact with a simple physical machine as each had their own dedicated mainframe. The control program CP created virtual machines, enabling users to run separate instances of CMS. It is a lightweight operating system simultaneously.
Yeah,
Now,
sure. I was working in the 90s and especially at the beginning of 2000 with something that is related to what was called VMware Workstation and also the server. It was an exe file that was running on Windows 98. I don't know if you have seen Windows 98 or used it, but I was working at that time since already 10 years. And we had the opportunity to start using this kind of virtualization created by VMware
yeah.
that then I was not thinking that they would have been so famous and they would have been conquering the worldwide market like we know they have been for a lot of years because they have been driving virtualization for a lot of time.
Yeah, and it's interesting because the evolution of virtualization technologies is not complicated to explain. If you understand that, for example, company like VMware in the 1988 to from 1988 to 1988 started with this technology, and after in the 2003 cent and KVM lastly in the 2011, we can see the evolution is important in this concept.
Yeah, absolutely. And especially Xen. Xen is not
Mhm,
really known, but it was the first virtualization that AWS used to run their EC2 instances in 2012, 13, 14, until they adopted KVM as a standard.
mhm,
So before of KubeVirt, that is the last icon that you can see in the presentation in 2018, there have been a real long history. And what we would like to focus on right now is what is this kind of thing.
mhm,
So I will talk about legacy virtualization. Then I think I will leave you for the cloud native because it's your special ability, especially being
mhm,
astronaut and similar. But legacy virtualization was just basic complexity. It
mhm,
was you have some hardware, you run on top of that virtual machines that are real machines, so you have to manage the Linux kernel or the Windows installation. And in a window, you would have access to a real machine that is very similar to a physical one, managing memory, managing CPU, managing whatever content you have inside, including virtual disks, and a lot of concepts that if you have worked with VMware or whatever other virtualization system you are familiar with. After this legacy virtualization, we started to see the cloud native
of course.
approach.
Mhm.
That is something relatively young.
Yeah.
Gerardo, cloud native.
Yeah,
What is
cloud
that?
native. Yeah, probably the people can sound interesting. Or it's not a new concept, being honest, but constantly cloud native, growing community, growing different projects or adopt them different technologies. But we can say that cloud native demands agility, scalability, and of course, unified management. If you will compare with legacy virtualization, it's not happening on this side because legacy virtualization means build monolithics. You have all in one place. Cloud native is decentralized. You can have different patterns. You can have different system working together simultaneously. So how probably different customer can think how I can put my legacy functionality into this modernist application or into cloud native stuff. So what technology can help us, Fab?
Cloud native. Look at clouds. Here we have real clouds. So we chose the right day for raining and clouds. Cloud native, you see here that I chose two icons in the presentation. One
Mhm,
is OpenStack, but it's really not legacy virtualization. It's younger than that. The other one is Kubernetes. So combine these two technology and you will understand what is KubeVirt. On top of Kubernetes, we use the ability of the Linux kernel to provide kernel virtualization management
mhm,
or KVM, and we go to something that is becoming a deployment of a pod that is really your virtual machine with a persistent volume claim attached and a disk. So we go to face the main pain points, if they are really pain points of the legacy systems, and see how we move out from that. Limited automation. You know that Kubernetes is automating
yeah, yeah, yeah.
everything. It's everywhere and high licensing cost. Then incompatibility. Today he talked about Kubernetes
Yeah, of course.
and cloud native.
Yeah, exactly. Because traditional virtualization tools don't integrate well with Kubernetes, leading to disjointed workflows and, of course, increased complexity. And, of course, we can talk about operational overhead and reduce agility. Managing separate systems for VMs and containers increase operational overhead and reduce the agility needed for the application itself.
Yeah, with all of this scenario, we have an idea of challenges. We will talk about challenges again. here in these slides where I wanted to spot really
Mhm.
what is the lacking of Kubernetes integration. It could be redundant, but remember that today, whatever is running containers, pods, deployments, Kubernetes, schedulers, it's really needed in our worldwide scenario for technology, including if you are using just components that are running on top of a cloud and you want to pair that Kubernetes service that the cloud provider is offering if you don't want to go for traditional systems. So you have the lack in VMware of Kubernetes integrations. We know that they tried something like Tanzu, but it's not really easy to understand, and you will have to relearn the technologies. And hybrid workload management is also something that is quite impossible. Now it's driven mainly by the cloud providers. So they do serverless applications, functions as a service, a lot of things that you can really do completing Kubernetes deployments without the need for getting crazy about learning providers and similar. Now, hybrid workload management with legacy virtualization system was a pain.
Yeah.
And then think about, you remember that when we certified, we studied resources.
Yeah, exactly. It is interesting because one challenge about traditional virtualization is resource allocation inefficiencies. Of course, because different environments often result in underutilized resources, maintaining separate infrastructure for VMs, and container increases costs, diverting resources from innovation to system on keep. And what happened with the limitation of the performance?
You can imagine that when you don't have optimal resource allocation and you have this kind of hybrid workload management nightmare, you will also limit your system with other performance issues. Like in example, you are missing CPU. How you can add a
Yeah,
CPU
exactly.
to a monster virtual machine? It's not scalable. So going to this hybrid workload gap, that is how we were thinking about management and the ability that we didn't have inside VMware because it was really something to learn. So Fusion, the vSphere, the client, the ESX hypervisor, many components that you had to learn as a specific bundle. Now we go for a better management, something that is innovating our strategy. And instead of having silos, we just use our laptop to connect via kubectl
Mhm.
and manage our Kubernetes nodes, where everything, the magic, is happening. And I want to leave you the pleasure of
Yeah.
introducing our friend KubeVirt. What
Yeah,
is it?
KubeVirt is an open source solution that extends Kubernetes by allowing it to manage virtual machines alongside containers. It means I can have containers communicating each other with virtual machines. It is crazy but interesting at the same time. KubeVirt extends Kubernetes API to manage virtual machine as a first-class citizens, combines virtual machine stability with Kubernetes automation. All the things that we can automate with Kubernetes, we can combine our virtual machines in order to use that. Unify management across VMs and containers. And of course, probably the most important topic that different companies love is cost savings.
Absolutely. Think about all of this, and now obviously KubeVirt is winning
Mhm.
over traditional virtualization system for these kind of things. KubeVirt was really invented or revealed by Red Hat. The ability of running in a pod with a disk attached, everything like a virtual machine. It's a quite strange thing because they always said to us that a pod should be a set of containers that are just running essential services. So when you think about managing a virtual machine, it's enormous, but it gives you the ability of managing everything from the open source perspective. So you'll find products to pair to your services. The workload integration is really easy because you just have to know how to create a deployment in Kubernetes. Think about you run a virtual machine
Mhm.
and at the site you have a deployment. that has the same service discovery, network policies. You don't have to learn the firewalling, a lot of things, role based access control, service accounts, whatever is inside Kubernetes. It has a unified interface. And you save a lot of money not just running your resources, but paying for engineers that will not have to learn a lot of the additional technologies. So think about future proofing, in
Yeah.
example, the
Uh,
CI/CD practices,
ho-
GitOps.
Honestly aligns with Kubernetes and CI/CD practices, ensuring long-term relevance. KubeVirt, as a solution, combines virtual machine stability with Kubernetes automation benefits for seamless management. Real-world success case study show, for example, lower total cost of ownership and faster deployment. And lastly, enhanced scalability and flexibility. KubeVirt offers better scalability, flexibility compared to traditional virtualization solutions.
If you think about all the considerations that we have to do when we are working with GitOps, if it is Terraform, I said earlier that we have a demo that we can write us and we will share with you. It's a public repo, so nothing secret. But I used to create that demo Terraform. That is infrastructure as code, meaning that you can add your CI/CD on top of that. And this is because operational efficiency is unleashed. You are able to translate that concept of worker nodes or agents. If, like in my case for the demo, I used the RK2 Kubernetes distribution, they are agents with a controller API that is extended for running virtual machines. So the KubeVirt extension is very rich. It's quite enormous to discuss in details. And you will be able to run by Kubernetes and KubeVirt exactly that summary that you see on the right side. So applications, deployments in Kubernetes, something that is very similar to a virtual machine because it's a pod. It's really a virtual machine. It has a disk persistent volume claim and the real world impacts.
Yeah, of course, legacy apps coexist with microservices. It's interesting because we can forget, we can forget the idea. I have legacy apps, so my application, I don't can, I, it's impossible to integrate with microservices with KubeVirt. That's it. You can't. You can do it. Seamless hybrid cloud portability is interesting. You can have different options. You can have, for example, your station with your computer, your servers, communicating with you virtual machines along with your cloud provider or instances, and improve performance and reliability.
Now, in the last minutes that we have, I would like to submit a couple of use cases that I found really interesting. I've been working in fintech for some time, having initially the challenge of working on Apache Mesos that was previous to Kubernetes some years earlier, but also contemporary. And I remember that one of the most important problems to solve there was migrating from monolithic to microservices. Think about the monolithic is the virtual machine, and you have everything running inside of that, and you gradually start to take each part that is running inside this virtual machine, containerizing the services and doing it inside Kubernetes. So you don't have to create services in another namespace. Everything could run in the same one.
Yeah.
And you gradually move what is monolithically inside one service on top of pods, microservices, containers, other namespaces. So this is really interesting appliance and example use case for a solution that is generally very, very researched. And a single use case that could be hybrid cloud in retail, you can talk about
Yeah,
that.
of course, because for example, unified on-premise cloud management for Black Friday scaling, for example, the retail company unified their on-premise and cloud management, enabling seamless scaling during peak times like Black Friday, enhance performance and reliability. The hybrid cloud setup improve performance and reliability, ensuring a smooth customer experience. And of course, good customer experience means cost savings and operational efficiency. The organization achieved significant cost savings and operational efficiency through the adoption of KubeVirt.
And think about that Black Friday application.
Yeah.
So only in Black Fridays you have to scale it up. The only way is to have Kubernetes. So the future is cloud native. I think the present and the recent past it is too. Legacy virtualization is coming to a dead end. Please move out from that. Also, if there are relicensing and similar, KubeVirt, I assure you that will bridge the gap between virtual machines and containers. We know how to do it. Embrace KubeVirt. For testing initially, write us. You will see that it will be fantastic to do demo and experience on top of that platform. And finally, I would say that we are done, Gerard.
Yeah. Thank you so much. We are open. You can scan the code if you have questions. You can know more about how we use Kuber, good demo that we prepared for you. Please go to LinkedIn, go to the scanner. Let us what do you think and how we can help you. And probably Fabrizio, we were very happy to help you or the people that want to learn more about Kuber, how to integrate this technology. Another important thing, okay, you can continue using containers or your legacy apps, but if you need make decision start from scratch, move to microservices, move to
Move to Costa
containers.
Rica. Move
Move
to
to Costa
Costa
Rica too.
Rica because it stopped raining, so it's time to come here. Cheers.
Bye bye.